Throws keyword is used to declare an exception. It gives an information to the programmer that there may occur an exception. So it is better for the programmer to provide the exception handling code so that the normal flow can be maintained. Throws is used to declare an exception, whereas throw is used to throw the customize exception, throw the customize exception. Throw keyword is used to explicitly throw an exception. We can throw either checked or unchecked exception. The throw keyword is mainly used to customize exception. Just to check it once. So I'm writing a static method here. If static void validate, and I declared here throws arithmetic exception. Which exception might come? Arithmetic. Throws is used to declare an exception. Now throw is used to throw the customized exception. See, this is not valid is not our exception. We are providing, we are providing. That means customized exception. Next. If A is less than 18, throw new arithmetic exception not valid. Close the validate method. Because of static method, directly we can call the validate method. Right. Here we have to pass the value. I am passing 60. That means A is less than or equal to 80. It go to the custom. throws new arithmetic exception, it has to print the not valid. Now see, run as Java application, click on OK. Now check it. So this is a customer java.lang. Arithmetic exception not valid. This is the customized exception. Okay. Generally, system is not giving that not valid. Okay. We are providing exception that is not valid. Okay. See, for java.lang. Arithmetic exceptions, actually generally this exception, whatever the arithmetic exception will give the system, here I am providing. That's why you can call it as a customized exception. Customized exception. See, if I have rest of the code in main function, okay, even after apply the throws, rest of the code will not execute. Only throw is to throw the exception. Okay, cannot handle the exception. Rest of the code will not print. Even after is the throw, okay, only throw the customized exception. It cannot handle the exception. Exception in thread main java.lang. Arithmetic exception not valid. Not valid. So this is about it. Now what I have to do in that case? Compulsory I have to the try catch again. Try catch. Exception EX. So we can the system.out.println EX, or one more we have actually EX dot print. This is also used to print the exception. Okay, what is the difference also? If you use the system.out.println or print stack trace, we'll see that. Okay, so that print stack trace will print the exception. Now see, so java.lang. Arithmetic exception not valid. Okay, rest of the code. Okay, instead of we use system.out.println. Yeah. Run as Java application. Click on it. See, simply not valid, rest of the code. The difference you have to understood. Okay, if we use the print stack trace only, it will print the error. That means complete error will come. Okay, here only the statement will get. Okay, what are the statement we have in the error? That one will get. Okay, observe again once. The difference between print stack trace and system.out.println. Okay. Not valid. The complete story will come here, and the rest of the code also executed because of it handle the catch. So the difference you have to understand. Okay, use the whatever the object or reference of the exception dot print access or system.out.println. Anything you can use. Clear? Understand? Throw and throws. See, throw is only used to customize exception. Only throws the exception. It cannot handle. If you want to handle again, we have to the try catch block. Clear, right? Parag?
Sir, I understand the throw for giving customized exception, but how did you use the throws here? Words.
See, particularly
throws.
when you want to throw an exception, for example, generally the system will generate the exception like by zero exception, number format exception. So those exceptions all we can use as customize also. Okay, customize is the message you have to pass your own. You got my point? If you want to give your own message, then use the customize exception. You got my point? Correct. So if you want to generate the system, directly we can use. If you want to generate your own message, okay, you can use the customized exception simply. Throws you can use. Clear, right?
Yes, sir.
Next. So this is about the exception handling. Now we'll go for the IO concept. IO, input and output. IO, right? Input and output. Use it to process the input and produce the output based on the input. Java uses the concept of stream to make okay IO operations fast. Java.io package contains the all classes required for the input and outputs. Here we have to remember the stream. Stream is nothing but okay. Generally, we are sending the data from one file to another file or one system to another system. Okay, the data sent in the form of binary data only. Okay, when you are storing, even when you are storing the data to the pen drive also, so internally it is stored in the it is transferred in the form of binary only, even though it is a textual data or anything. Okay, let now see. IO, input and output, used to okay process the input and produce the output based on the input. Java uses the concept of stream to make IO operations fast. Java.io package contain all the classes required for the input and output operations. Stream. Stream is a sequence of data. In Java, stream is okay composed of bytes. Okay. It is called stream. It is called stream because of it's like a stream of water that continues to flow. Okay. Now, generally we have three streams. System not out in an error. Okay. Error. Okay. When we have any error, it will give the system will give an error and input statement, output statement. Okay. Next. Output stream. What is the output stream? Java application is just an output stream. Okay. To write the data to the destination. It may be a file, an array, a peripheral device, or a socket. Okay. Now, Java application data is sent to the destination. See, the data will transfer in the form of binary zeros and ones. Okay. Next, input stream. Retrieve the data from the source. Retrieve the data from the source. Input stream. Okay. From source to Java application. From source to Java application. Reverse. Next, output stream classes. What are the classes we have? So output stream class is an abstract class and it is a superclass of all classes representing an output stream of bytes. An output stream accept the output byte and send them sync. Okay, now see. Write, okay, plus close. Three methods, write, plus close. Input, read, available, close. Available, rarely we are using. Okay, so read and close. So next, file input stream and output stream classes. Okay, to write the data from the Java application to the destination, we can use the file output stream. File output stream is an output stream for writing the data to the file. If we have to write primitive values, then use the file output stream class. Instead of for the character-oriented data, prefer file data. But you can write, okay, byte-oriented as well as character-oriented with the help of file output stream. Okay, file output stream. Now see. Okay. We'll let this program first. First we have to the import to IO. Is capital in stream is capital. Okay, right now see first point. File output stream. Okay, for this new file output stream of abc.txt. Okay, here you can give the any name. I'm giving suri.txt. So defaultly it will create it in the where I am saving my file. I am saving my file in the F drive. I think no, actually 5 a.m. at desktop. Okay, in that folder only it will be stored. Okay, next. So into suri.txt, this data I want to send. S is equal to Sachin Tendulkar is my favorite player. Okay. Now, directly we cannot send with the help of file output sim, right? Simply I have to convert into the binary data. Okay, now see. Byte B is equal to S dot get bytes. Okay, that means string is converted into the bytes. Next, effort. Okay, dot write B. That means, okay, what are the data we have in the B that will be right in the effort. Effort means suri.txt file. Okay, so it will be supply the data to the suri.txt file. Okay, next to close this. I'm writing try within the try. Now here I'm giving the finally. I already told you finally is to close the stream and close the connection. Okay, finally. Next, close the main try. This statement we have to give the out main try. Right, now see. Catch exception system dot. Okay, in the system, what we have to give? S capital. Here, you can understood nested trials. Try within the try. Okay. So in these cases, only we can use the nested try within the try. So file output stream, F4 is equal to file output stream, suri.txt, and in the try, I am sending the data, okay, and okay, write the data. So before closing, we have to use the finally because sometimes it may not close properly, but finally will close forcefully. That's why you have to use the finally, okay, finally. So for the main try, I use the catch block, okay, right? This is generally we are using in the form of, okay, nested. When you use the nested, use the finally and catch. Both we can use here. System dot out dot println. File create. Run as Java application. Click on OK. File created. Go and check it. Where is my folder? Desktop. 5 a.m. In this you can check it. Suri.txt. 5 a.m. Example SRC. Okay. At 5 a.m. SRC. 1 minute.
Example, sir,
Yes, example. I'm checking.
on first row,
Example. In this we have. Right, now check it.
SRC.
Sorry.t. Okay. T.
Sorry, there.
Right. So file is created. This is actually default position. I want to change the path also I can change. Now see. I want to store in F drive. Just select the F drive here. Control C. F drive. Okay. Suri.txt in F drive. Now run as Java application. Click on OK. So file created. Go and check it F drive. Sorry. Okay. Sorry. Right. So this is how we are creating the file and send the data to the file. Understand, right? This is about the file output stream. Clear? This is for writing the data. Next. For reading the data, we can use the file input stream reader. File input to stream reader. File input stream obtain the input byte from the file. It is used for the reading the stream of raw bytes such as image data. For reading streams of characters, consider using file reader. It should be used to read the data, read the byte-oriented data. File input stream obtains input bytes from the file. It is used for the reading the stream of raw bytes such as image data. For reading streams of characters, consider use the file reader. It should be used to read the byte-oriented data. Okay, now see. File input stream. Now file input stream, here I have. If you use like this, it is getting from the 5 a.m. folder. If you use the path, from the path we can get. Try while if fr dot read greater than -1, that means at least 0th item is 0 is there. So array start with 0, right? That's why 0 is there. Then only the data will be retrieved. So, now, finally, FR dot close. Close finally. Close catch. For close means try. And catch. Catch. Okay. Now read the data from the, okay. What is there? Okay, right. Sachin Tendulkar is my favorite. If you want to give the line by line, simply we can give print. Sachin Tendulkar is my favorite player. Okay. Reading the data and writing the data. Okay, with help of file, input stream and output stream. See, I don't want to convert into the binary. I want to send the straight away textual data to the destination. I read the textual data. Okay. So we'll use the file reader and file writer. File reader and file writer. Okay. File writer. So file input stream reader and output stream reader for the both file binary data as well as okay textual data. But textual data has to convert into the binary. Then we can use that data. Clear, right? Understand? So next. Next. Buffered input stream data. For supporting purpose. For supporting purpose of file input stream and output stream, we use the buffer output stream. See, buffer output stream class cannot create any file. It will work just like a internal buffer. Now see. Buffer output stream class is it an internal buffer. To add more efficiency, then write the data directly to the stream. So it makes performance fast. Buffer output stream. Now see. Okay. Instead of writing the data directly into the file output stream, we use the buffer output stream. The complete internal work will be done by the buffer output stream. Only okay, creating the file will do by the file output stream. Observe clearly here. Java dot, speaking dot, sorry, IO dot IO. Okay, it's now first. Try. Okay, new file output f1.txt. Now, buffer output stream be out. F out is now okay. Hold by the buffer output stream. That means whatever the data okay transfer to data writing to the f1.txt, everything do by the f out only. But supplying the data to the f out by the b out. Now see. Try. Okay. Now string converted to the binary data, and b out dot write b. Okay, we first we are writing to the b. Then b out is supplied to the f out. Flush. The flush is must should be we have to use, because sometimes okay, the data will not send properly to the f1.txt. In that case, we have to the flush. Next, finally, b out dot close. Okay, close the try. Let's catch exception yes. Convert out dot println yes. Okay. File created. Yes, okay, now run as Java application, click on OK. File created. Go on, check it. Desktop. 5 a.m. Example F. Sachin is my favorite player. That means instead of sending the data directly to the destination, if you use the buffer output stream, okay, so execution will be faster. Got my point? And the burden on the file output stream object also decrease. Clear, right? Understand? Yes. Same thing, file input stream also. Sorry, buffer input stream also. New class. Test buffers input stream. Import java.io. Reading the data. Close. Windows close. Close. So main try. Catch. Let's capture. Okay. Now read the data.